So everything appears to be working. That's good. Let's see what the latency is like. Everything appears to be working. That's good. Let's see what the latency is like. Oh my god, my first number. Hi, Boris! Why is my chat not working? Come on. Hello, live chat. That's nice. Let's see. Look at my YouTube channel. I don't got my live chat in here. Come on. Go live. Yeah. Fuck, I just saw you. Where'd you go? My bitrate is too low. Let's see if we can update that. Boop, boop, boop. Not good. 6800. Boop. Should be better now. So how do I get this chat in here now? Let's see. So I can go away. Open this chat in here. Place this here. Make it see through. Okay. I hope the bitrate is high enough. Oh, this trash quality. What? Nope. No way, it's actually this quality. It looks okay. That's good. Let's see. Now I should be a good streamer, switch my stream to my programming stuff. There we go! Can fly around in our game engine. We have a little schlorps. They're flying around. Whee. So... okay, first I'm gonna post my stream link somewhere. How do I find this? This shouldn't be shared. Yeah, it isn't. Good. Your channel. This one. Bloop. I'm gonna get this. I'm gonna go in here. Coolio. think I got this set up now. Got this set up now. Got my Skyrim ambience music. Got my mic. Got my IDE. Got my slurps. Okay, so the problem at hand. Okay. The problem at hand is, let's go to graphics. If we disable the present mode, we use an immediate present mode, we will see that it is compiling my entire program, because everything depends on this, right? And if we fly up now, we can see that we only have about 80 frames per second in a bad case, so that's pretty shit. If we look away, it's like 200. This is very good GPU, so one of the things we would like is we want to have a BVH which we can use to find intersections way more efficiently, because currently I'm testing all the ABBs of all objects for every ray, and that's super expensive. So for this I'm gonna, let's see, I need two things. I need Jako's papers, and I need to implement. Oh my god, Derek is also here! So nice. I need two things. At lower audio levels, my ears bled. God damn it. How do I lower audio levels? Okay, Derek, you're fixing my audio now. You're responsible for that. Hello, Doruk. How is this? Is this any better? Beep boop. I have no idea what this latency is like, so I think so. Okay, that's good. As long as the ambient Skyrim sound is not like louder than whatever I'm saying. Okay, let's close this. Let's how can I do this? Okay, I'm just gonna try to find my BVH somewhere. It should be in Coggers, examples, voxel, no, ray tracer, BVH.rs. Let's see. Now we close others. I think you should lower the ambient sound as well. It's just your actual mic was speaking, so I should reduce this one as well. Okay. Is this any better? Freaking hope so. Okay. Let us control all. Let us create a new file, bvh.rs. We're gonna use this as a base. We're gonna close this one. And now let's have a look what we can use in here. We don't need a, well, we do need a ray. We need rays for our, so the current plan is, we saw the Slurpees flying around. Let it load. Slurpees are flying around currently. This is a predefined pattern. The Slurpees should use some form of boids to fly around in the scene. They should fly around the island in little clumps, and they should not hit the trees, and they should not hit the rocks, but they should at some point fly around. If they see you, they target you, they fly after you, they try to get you. You have to make sure that you don't get caught by the Slurpees. That's pretty much the idea. So for that, for Boids, to avoid terrain, to efficiently avoid terrain, we need some form of spatial indexing. So to do this, we can, let's see, so we have to make a BVH. Using that BVH, we can we can shoot rays from each of the Slurpees. We can check when we're going to intersect with terrain, then we can steer away from that. Then on our GPU side, we should also be able to use this BVH to more efficiently shoot rays. And have a bunch more objects, I hope. Because I'm currently using, let's see, less than 5% of my the data that I can use for my voxel array. So I want to have about 10 times as many objects that we can currently see in the scene. That would be amazing. And that should be good enough. And it should run on devices which are, you know, not great. My GPUs are 3070. I think a normal 3070. So yeah, BVH. We need a BVH. For that, we need a few things. So let me check OBS. Is OBS still doing okay? OBS seems to be doing okay. Sick. ABB, BVH node, file name. So in here we're gonna load in a bunch of triangles, a bunch of indices, yeah, a bunch of BVH nodes. Okay, we don't need this because we're not doing anything with triangles. We yeah, we don't need triangles, we don't need indices, we need BVH nodes, and we need centroids because that's how we build our BVH. Then in here we don't need triangles, we do need rays, origin, T, direction, primitive hit, D reciprocal, and some padding bytes. This is for the GPU, but I don't think we're gonna use this for the GPU, so it should be fine. Then the most important parts of our BVH is the build BVH. This sets up a bunch of stuff, the subdivide, this subdivides the stuff. Partition shuffles all our axis aligned bounding boxes. Actually, partition shuffle does that. Partition only does the part where it finds the pivot. So it tries a bunch of different pivots, and so we create a pivot, then we partition shuffle all our data using that pivot, then we calculate the bounds of our axis aligned bounding box, then we get the area, then we use the surface area heuristic, that's what it's called, and we check if the cost is better than the optimal cost, and then we use that axis and pivot position, and we store our cost and we store our our pivot. Get area, this calculates the area of our axis aligned bounding box. Partition shuffle, I just explained, it just shuffles all our using the centroids of our axis aligned bounding boxes. We shuffle our bounding boxes to make we shuffle our bounding boxes in an order that keeps the Actually, I don't know, what does this do? If centroids, if the axis is less than the position, then I plus 1. Else we oh right, so we use our pivot point in a certain axis. So our pivot is, I guess, anyway, if we have a giant array, this one makes sure that the centroids of on the left of our pivot point are on the left of in our array, and the centroids in our to the right of our pivot point are in the right side of the array. That's what this does. Calculate bounds. This is annoying, so we iterate from first to first plus amount. Yeah, that makes sense. Then if centroids, yeah, right. So this calculates an AABB around all the nodes that are from the some first element in an array and counting up to some amount in the array. So we use this to calculate the access line bounding box on the left half of the array and then on the right half of the array, and then we know our total, the size of our two bounding boxes of our primitives, which reside in the BVH. And we have a lerp in here. Sounds good. So we need all these parts, build a BVH. Let's see if we can use any of the primitives that we have. So BVH nodes we need. The only part that we can probably replace is our AABB, because instead of AABBs, the instances of our models are these thingies, and preferably we can directly operate on this array. However, we shouldn't be reordering this array because this thing is massive. So, are we reordering anything anywhere? BVH is a set of BVH nodes. BVH node has a left first and a count. Oh, okay, but this will very definitely oh fuck. This will most definitely reorder some stuff in our BVH. So triangles, yeah, we map that. Calculate bounds, subdivide, yeah. Partition, yeah. BVH nodes, yeah, we can reorder that, that's fine. BVH nodes. Calculate bounds. I'm gonna guess that the partition shuffle is gonna... Right, this one is the indices. Okay, we need the indices buffer. I just removed that, but indices. There we go, indices. In here, I'm gonna mod BVH. Bloop. Then it's gonna start hating this thingy. Bloop. Zeroable. Yeah, factory. Bloop. Seems to work. Triangles. So let's do this some other way. We're gonna Instances spec instance model instance. We need these ones. Yes. Okay. Then we don't want to modify this. We just want to iterate over the instances. No. This one. Bloop. Then that's a T. Can we do T dot let's do this one plus T dot transformed divided by 2.0. Bloop 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 bloop. This should be everything. Okay, so this way we get. Oh my god, I need another one. This way we got the centroids, I think. Should be. Cell centroids. Yes. Then in our BVH nodes, left first 0. This is the number of instances. Oh, this one is the number of instances. Not in here. Yeah. Then calculate bounds. Set bound. Okay, we're gonna set the bound of. Okay, this takes a BVH index, updates the BVH node using the AABB. That makes sense. New node index is 2. Solve the triangles. I don't want to deal with this. There we go. So somewhere in here is gonna, yeah, in here it's gonna complain about our triangles. And it has to calculate these bounds, quite a bunch. So instead of passing in this one, we're actually gonna pass in the instead of passing in the length of the instances, yeah, we're gonna pass in the instances just like here. Bloop. And bloop. This one's gonna complain about our instances. Yeah. Come on, this instances dot len. Yeah. Why do you not work? Oh, you're a U size, not a U32. Okay, there we go. In here we have a vertex, vertex, vertex. Yeah. So we don't need any of these anymore because we no longer have 3 points. We have 2 points because we already know the AABB of our model instance. So in here we can do this one. Take. Yeah, use the instance. Yeah. Okay, we're gonna bloop bloop and bloop and bloop. And in here we're gonna take our max. We're gonna take our transform min. This is gonna complain. It's not complaining. That's good. When do we use the centroids? Ah, for the partition shuffle. That makes sense. I don't know if we ever want to calculate bounds using the centroids. Ah, that makes sense. Yeah. Okay, so the reason why we can pass in centroids here and then it calculates the ABB across all the centroids is because in here we use let's see if I can stream my browser. Boop, boop, boop. Screen. Let's see. Firefox. Bloop. I'm gonna window capture. Who's sending me stuff? Nope. We're gonna stream this one. Yes. Great. Jaco Picker, my lecture. Let's see, is the screen cut off? It sort of is. Okay. So in here we can see there's a bunch of articles. BVHs. Hey, look, this thing we're building, but for voxel objects. So, let's see. Let's see, is he talking about the splitting heuristic already? Ah, here you will. So, there's a bunch of different splits we can take for our objects. So, I don't know if there's any better pictures. We can clearly take a split in the center, like this, as we see in here. However, in this case, that will only, I don't know, this will have one AABB with a bunch of objects, and then one with only 2. So, preferably, we'd probably want to split over here, slightly more to the left, and then we get way smaller, or slightly to the right, so we got one super small AABB for a single object, then a separate AABB for all the other objects, and then we split again in the center roughly, and then we get then we have a total of 3 axis-aligned bounding boxes, which are all very small, and that's exactly what we want, because when our axis-aligned bounding boxes are small, then our arrays will have a lot easier of a time eliminating parts of the scene that we do not have to hit. So, when calculating where to place this line, we don't simply place it in the middle. We check the bounds of our centroids, and then we try a few different bins, as we call them. Let's see, we have bins here, so I use 8. So down here we can see these dotted lines. In this article they're placed exactly on the centroids of our objects, but I place them in interval. I always place 8 of them. I always place 8 of them across the this area, this ABB. So yeah, that way we get a more. We don't have to test every single one of these centroids for as a pivot point, but we can use yeah, just 8 of them. So this makes sure that we're not testing like a bunch of stuff that we shouldn't need. This just discretizes our pivot selection, I guess. However, in here we once again need our instances. Let's see. Bloop. Instances. There we go. Calculate bounds. Oh, this is gonna be so annoying. This doesn't work. So instead of passing in a vector, we can pass in a slice. Oh, bloop, bloop. Because the slice also accepts a vector, which is nice. But instead of that, we can also do. Oh, don't remove the entire thing. Instances reference dot slice slice, yeah. And then in here we should be able to do 0 dot dot bb1 count. Yes. Actually, oh, this entire thing doesn't work anymore then. So instead of using first here, we're gonna remove that. We're just gonna pass in instances. We're just gonna iterate over all the instances in this slice. But because this is a slice instead of a vector, we can send parts of our vector in here. So we can say that only the first 20 elements of our vector is going to be passed in here. For I in instances. And we have to make this a range like this. Remove all of this. This should work. But instances. Okay, we can simply remove this. This is fine. In here we can simply remove this. This is fine. Yeah, because we have to count them all. So here we have a start. Let's see. Our start BB1 count, and then in here we are going to so we need our start. We have our yeah, count is the total number of objects, or total number of objects minus BB1 count. Then we're gonna we're gonna remove this. I think this one makes sense. Start plus BB1 count. Or is it pivot? Oh my god. I think it's gonna be pivot. Because pivot is the, yeah, until pivot, and then in here we're gonna do the exact same, but from pivot till we're gonna start at pivot, and then we're gonna not iterate until here. I don't know, it's gonna be like pivot plus bb2 count, which might be the same as count. Let's see if this works. Type cannot be indexed by SU size. SU size. Does this work? It does. That's ugly. SU size. Bloop bloop. SU size. Bloop. This is gonna be fine. Okay, so now we pass in like parts of this string, specifically parts within this range and this range, and then we calculate the bounds of those sets of objects. Okay, here we have another one. We have to fix this one as well. BVH nodes, count. Okay, so let's copy this stuff again. Wait, but partition is so mean now. Actually, it shouldn't be. We just have to pass in our instances every time. Bloop, bloop. And then, oh no, what did I do? Why did I put it here? Be gone. This works now. That's good. Okay, there's subdivide. What's wrong with you? You need the instances as well. Instances, yeah. Let's see. Bloop, bloop, bloop. Oh no, I'm not using my coding screen. Oh. Okay. Let's see. That's gonna be so annoying to remember. Calculate bounds. We need to calculate. let's see, calculate bounds. What do we need? We need instances, which has to be a slice of this stuff. Let's see. Nope. We're gonna take this. We're gonna start from start. We're gonna go until start. Those left then. Yeah. Now we're gonna remove these. This should work. What's this? There we go. Bloop. Then in here we need the same type of pattern. We're gonna start at the pivot, and then here we do. This should be pivot as well. Pivot. Does this work? What's wrong with you? Why are you in I-32? Wow, you're U-32. What's wrong with you? Why is count an I-32? Ah, right, because our first one is a -1. Ah, that makes sense. Why don't I just has I-32 here then, and then remove this? Would this work? No, because this is I-32. This is gonna work, subdivide in instances. Okay. So now we should be able to calculate a BVH across our all our stuff. Ew. Where we should go? Build BVH. Let's see if this works. And also, quite importantly, let's see if this. What do I rebuild this stuff? Here, update world, remake instances, gen GPU models. So in here we should have proper instances. We're gonna do this one. Bloop. Is this public anywhere? Build BVH. I don't know why I did it like this. This is annoying. I'm gonna remove this impulse in. Build BVH. Okay, so we can do let BVH equals BVH. No, we can do it like this. And then in here, fill structs, and then in here, the default. Boop, boop, boop. Oh. Bloop. Bloop. Okay, then we can do BVH. Build BVH. Yeah. This argument takes one argument, 0 were supplied. Okay, so then we can go to dragcubes info dot model world dot render data dot instances, and then we have to make this mutable because we're editing the BVH, and then in here BVH dot let's see if we can do a TBG like this. This is gonna completely mess up my console. Let's see what it does. Index out of bounds. The length is 0, but the index is 0. Okay, let's get to it now. Alright, I deleted all the starting code. God damn it. Because BVH nodes should be self.bvh nodes indices equals the right, we do one of these instances dot length. Okay, what do you mean? Oh, fuck, like this. Okay, self dot centroids. We're gonna calculate that there. Okay, self.bvh nodes equals fac loop default, and then we need, I think, this one multiply by 2. What do you mean? Why do you not have a default value? BVH node. This should be able to have a default. There we go. BVH nodes should be filled. Should not error on this immediately. There's a separate issue. BVH nodes. Instances.length. Huh. Why? What's the length of our instances? Should I just dot max 2? And then we make sure that we always have our initial BVH nodes if the instances folder is empty. Okay, a node crashed somewhere else. Out of bounds, the length is 602, but the index is 602. Let's see. Because okay, I'm DVG. Put this in here. Subdivide. This is. Why did everything move like half a meter? Okay, in here we're gonna DVG our ABB. Let's see what is in here. So, our BVH.bvh nodes. Our instance's length is that. Our ABB is that gigantic thing. Our BVH.bvh nodes. Where's this? Okay, that makes sense. Okay, so now we have a length of 301. Right, okay. Let's now go back to Yakko's article. Nope. Let's see how he does this thing. Okay, so what Yakko does is he initializes a bunch of triangles, intersect triangle, yeah, okay, we test if we had something, okay. Our BVH node, how big should it be? Our BVH should be the number of items multiplied by 2 minus 1. I did that. Let's see what's wrong then. Because this would mean that somewhere in here, this index, I don't know where you're calculated, pool index, you're in the subdivide, yeah, pool index plus 2, why is our pool index like that? Would this make sense? So XYZ, XYZ. I don't know why this is in this weird range. I don't think that's correct. The Y range might be correct. The Z range doesn't look correct. Calculate bounds. Yeah, transformed ABB max, transformed ABB min. Max point, min point, yeah. That makes sense, I think. So, what does it crash on? Crashes on this. DBG, okay. If you're ever stuck, you don't know what to do, add more DBGs. Uh-oh, what's wrong? Pool index. Can I just do this, please? Please? Oh no, right. Oh, that works. Okay, so it's doing exactly what I expected. It's incrementing a bunch. Current BVH index. We're also gonna print that. We're gonna print the start. Nope. Instances. Yeah, we know that there's 602 instances. So I don't think it's doing very well. Get area, yeah, partition shuffle, centroids. What does this mean? Oh, yeah, this is correct. Yeah, makes sense. However, it's kind of sus that this start is always 0. Our pool index, our current BVH index. Yes. Let's see. Let's see in here. Actually, let me quickly set up something. Well, I don't want to bother with that. In my OBS, I should be turning on the thing that makes the windows switch every time I alt-tab between Firefox and VS Code. So that I don't forget to switch it, because I do forget. Okay, so what's the issue here? Fill lag somewhere. Calculate bounds. Start to pivot. Pivot plus BB2 count. Makes sense. Yeah, okay, in here we were doing some other funny shit. Start plus left count, pivot plus right count. Yeah, that makes sense. BVH node, ABB. Okay, right. We still need those for benches. Shit. Debugging and BVH. That's so much fun. Could this be caused by our pivot finding stuff? Let's see. Where's our pivot finding stuff? Over here. Yeah. Okay, so if we dbg all this stuff, and this one, and the pivot, and the optimal cost. Let's see what happens. Well, our optimal cost always stays the same. The optimal pivot stays 0. Optimal position is 70. Okay, so this is always the same. Sick. Because we are never ever... I feel like we're skipping steps. So if instead, okay, I'm gonna turn this into a headline, and I'm gonna place it here, and I'm gonna set up this to axis, position, cost, pivot. Let's see what happens now. Oh my god, of course. Boop, 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 boop. Let's see. So we panicked. What are you doing? Why is the pivot always 0? Pivot partition shuffle. This shouldn't happen. Oh. Why is the... Okay, so these are the axes, right? So first we have our axis. Our axis is what we iterate 3 times because we have 3 axi. Then our position, for some reason, is never changed in each axis. Then we get the cost. Are we doing something wrong here? Max point, main point. So what is going on? Transformed ABB min. It would seem like what's this? Okay, the ABB of our instances. Let's see what that is. ABB Nope. Okay, let's see. A bajillion times exactly the same. But oh yeah, this is not correct. Okay, so in our ABB, our min and max are the same. That's bad. Transformed ABB max. We're using this one. Self.indices. Oh, this is centroids. Self.centroids. Do we ever fill our indices? We never fill our indices. Oh, I'm so stupid. Okay. So our indices are all 0, but they should be 0 till the instances length. Yeah. Collect. Right? Okay, not like this as U32. Then our indices will have 0 till the max number, because this is the anyway, this is using the wrong instance, although that should only use one instance then. What? The length is 20, but the index is 269. Okay. Instances. What the fuck? So, in here we set the instances. Indices. Yeah, each index should reference one instance. Okay, where do we break? Instances. So we have two interactions. Over here we have one. Over here we have one. I don't even know which one is broken. Index out of bounds. The length is 20, but the index is 269. Oh my god, that's so annoying. Because I switched this from a vector to a slice, and then these are no longer slice start. Yeah, so U32. I switched this one from a vector to a slice, but then the indices in this index buffer no longer match this one. So we have to subtract wherever the slice starts. Or add. No, subtract wherever the slice starts. Minus slice start. Yeah. Like this. We might get more issues if we do this, though. Minus slice start. Yeah, don't mind the formatting. The formatting is gonna fix itself eventually. Oop. Okay, never mind. Minus slice start. In here we're gonna, Jesus, so many references. In here we're gonna loop, pivot, yeah, calculate bounds. That's the entirety, so that's gonna be 0. Anywhere else? Any other offenders? Pivot, start, calculate bounds. Okay, so here it's 0 again. Okay, seems to be fine. Are you okay now? Let's see if our BVH builds. No, it still does not. Okay, that access line bounding box looks way better for initial one, but we still get an error over here. Minus slice start, so should this be plus? Oh my god, that should be plus slice start. Yep. Right? No, it shouldn't. No, it definitely shouldn't. Because indices is gonna have like the big number, the 300 number, and then our slice start might be like 290. So then we have 300 minus 290, and then in the instances that we currently passed in, we're gonna use, then in here we're gonna use only 10 instances, and we're gonna index using 0 to 10 in there. That makes sense. So this should be correct. The length is 31, but the index is, oh my god. Oh. Print line. Yeah, and using an actual debugger is like a big no-no. Why would you ever do that? Length, yeah. Yep. Oh, and I can also do centroids. See. So sad. 0, 26, false. Okay, 0, 301, true. By the way, the command set, so how my project is currently set up, I have a server and I have a client. I can start my server using, why did you break? Okay, let's try again. So I have a server, I can start it with S. I have a client, I can start it with C. Client connects with the server. Although it currently barely does anything, it just sends the player location every once in a while. And I map this to S and C using on Windows it uses this one. On Mac it uses this one. And on Mac there's a bunch of extra steps because if we place it in these specific folders, all the data and our icon, then we can have the little dragon icon. If we run it, you can see it at the top left. I think you should be able to see it. Okay, you can't see it, but if we launch a program and it actually runs, you can see the little icon, and on Mac it has the little icon and so on. Okay, let's get back to the problem at hand. So, this is our, that's a bit sus. So our BVH is very big here, over here at the start, and then and then in here at the start it's this. During the partition phase it's suddenly way bigger. That should not be possible. Let's see, our AABB, that's this one. Yes. And we have all that stuff. Okay, we're gonna use a DVG. DVG. Nope. fat L. Slice start 0, 30. Yeah, makes sense. Oh, none of that makes sense. Or the print location of that stuff doesn't make any sense. Start and pivot. Start, pivot. So 269. Our slice start is 0. Yeah, makes sense. So you start until pivot. But the index is 269. Why do you have a problem with that? Calculate bounds. Oh. But this shouldn't calculate the bounds of the entire thing. Right. Oh my god, that's gonna make everything so much more complex. Why did I even switch to using slices? Seems like a silly idea. Okay, let's see. Can I get my non-slice shit back? Okay, so that's broken out. Blah 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 blah. Here I was fixing up the slices. Okay, this is a very annoying hotkey to. Where are you in here? This is gonna be like F1. Fucking hope that doesn't kill my PC. There we go. Okay. So this uses slices. Shouldn't. No more slices. I actually hate slices. Okay. Now no longer use the slices. It still does. Well, at least it doesn't use. Okay, we're back to the amount. Okay, we just removed the triangles. Okay. What are you yapping about? Okay, so instead of doing all that shit, instances. Okay, we're going back to this part. In here, we're just gonna pass in. This is once again proving to keep it stupid simple. I don't know. KISS, I think, is the abbreviation. Keep it simple, stupid. That was it. Instances. Calculate bounds. What's wrong with you? Ah. Instances shouldn't go here. It should go here. Instances. Nope. Okay. That works. Instances. This should work. Yeah, that is the correct position. In here I'm gonna do instances, and then that one, and then max. I should be able to just place it here, and then in the min point dot transform min, yes, plop and plop and plop, because we already know the min at max. Calculate bounds. So in here we're gonna need the instances. It's gonna be so much simpler. Instances. In here we need, oh, not there, and then in here as well, instances. Okay, what is wrong with you? Instances. Okay, any more instance problems? Subdivide also uses instances. There we go. Boop. Instances. Boop. Oh my god, now these silly squiggly lines are back because I Ctrl-Z'd my entire progress. Okay, so indices, no, self.indices dot equals 0 to 2 instances dot len su32. Okay, then we collect, and then we get a perfect range from 0 to the length of the instances. Okay, let's see. We had another part in here. I forgot what it was called. Oh, BVH nodes. I should initialize that as well. Self.bvh nodes equals the in here I should add debugger or default again. In here back this one, the default instances len multiplied by 2 minus 1. Can steal this from Yako. He also uses exactly that range. Okay, let's see. Let's try again. Attempt to subtract with overflow. Ah, right. Let's see, like this, dot max, like this, and then we always have at least one node, I guess. It's doing stuff. It's doing stuff. It's good. That's a bunch of stuff happening. Why is it breaking? It seems to be breaking somewhere. Oh no, it's fine. Where's this? Where's this print? Print. Oh right, it's printing the entire BVH. 0, 0. Okay, then we got two thingies at this index, and then this is the ABB of that thingy. Okay. So, okay, I'm gonna remove these annoying squiggly lines. Bloop. I'm not dying, you are. So this DBG, let's have a look. Should be able to comment this out. It's gonna do a bunch of stuff. In here, I'm gonna. So in here, we are going to. So we should have a BVH now. I think in here, no, in here, we made the BVH. Okay, we have a BVH. Then, Gen GPU models. This shoves everything to the GPU. Let BVH buffer equals this entire thing. But BVH buffer init descriptor. Okay, so instead of model descriptors, we're gonna pass in a BVH binding volume hierarchy with a reference, because we don't always want to destroy it, probably. There we go. This one we're gonna remove. BVH, what's wrong? Expected slice reference. What's in here? We have BVH indices, BVH nodes. Do we need the BVH? We definitely need the BVH indices. We definitely need the BVH nodes. I don't think we need the centroids. So we can do this one, BVH nodes, buffer. This is gonna be fine. Oh, okay. We're gonna take the reference. That should give me a slice. Yeah, okay. We're gonna do exactly this thing, but instead we're gonna do indices. And in here we're gonna do BVH indices buffer. Let's go. Oh, in here. Indices. Yes. Yes, queen. Boop, boop, boop. Bloop, bloop. Okay, in here, indices buffer, BVH nodes buffer. There we go. Oh, let's quickly check if these are correctly sized. Indices is U32, this is BVH nodes, this is exactly 32 bytes. That's sick. Let's see, this is 4, that's 4. Yeah, that's good. Yes, I am Dutch. That is correct. How did you know? BVH, this one. Lekker man. Exactly. You know what it is. Oh, you're from Africa. Sick. Okay. Coolio. So, update world. Change GPU models, BVH. Okay, then we get a GPU model. Then we're gonna use this GPU model in a bunch of places. Rebuild instances buffer. Oh my god, do I have to do that again? See, we got options in there and some nice functional programming. Yeah, I completely agree. Freaking love Rust. Okay, let's see. Where do we bind this kind of stuff? In here we bind this kind of stuff. Intersect, bind group. Yeah. So we have to add some more bindings because we want to bind our BVH nodes buffer. BVH. I do Scala, but I would love to try out Rust for game dev at some point. Yeah. Try it. First time I tried it was Advent of Code, I think. Don't worry. First time I tried Rust was during Advent of Code, and that was a very nice introduction. I can definitely recommend that. So I guess in here we have a texture bind group. Well, this is a 6 scam. These aren't textures. These are buffers. Trace, buffers, bind group layout. Yeah, okay, then we can do 5, 6. Compute, buffer, storage, read only, true. Yeah, okay, makes sense. Control S this. Okay, now we're correctly binding all our stuff. Then on the GPU, we can go in here, and we have 2 additional buffers. This contains U32s because this is the BVH indices, and this is BVH nodes. Which means we have BVH nodes. What libraries are you using to make this project? Well, all of these. So part of it is for the server side. It's probably easier to check in here. So these are my shared libraries. ByteMug, very useful for bit manipulation. Random, noise, Serta, tracing for logging. I forgot what this is for. Glam for math, Dolly for camera movement, JSON for JSON. Makes sense. Then on the server we have Tokyo, most of the ones that I just mentioned already. Anyhow is useful for errors. Goxies is my main library. And then we have our client. Our client makes use of Polster for blocking async waiting, image for loading images, half for half floating point values, parking lot for async primitives, rodeo for audio, I think, GuildRS for controller support, and then when it's WGPU, Naga for graphics, and eGUI for the UI. That's everything I use. Let's get back to making. Where is our BVH? Okay, let's put you here. Nope. Is that properly visible? Yeah, it is. Okay, so then we have to copy paste all of these. Let's remove this. Oh, it's so nice. All this code is just correct out of the box because WGSL uses the same like syntax. BVH node. Okay, this should work. We're gonna put a BVH node in here. We're gonna have an array of BVH nodes. We're gonna set this to 5, set this to 6. This is a storage buffer which we read from exclusively. Interesting, thank you. Yeah, I hope you can also start doing some stuff. It's very nice to write GPU code with WGPU. You should really try it. Intersect, BVH node, BVH nodes. Okay, now we're gonna once again steal code from another project I have. Because I do not want to write the entire BVH traversal again. It's gonna load in here, copy this. Okay. In here, let's do some temp to GSL. Okay, we're gonna start stealing code from here. Thought you would use Vulkan for rendering, but I don't know that much about graphics programming. Well, Vulkan is very verbose and complex, and WGPU is not. WGPU is a library on top of Vulkan, and instead of having to define like a bunch of stuff, keeping track of a bunch of memory, in WGPU you can mostly say stuff like, oh, I want a size for my texture, I want a texture with these MIPs and these, I don't know, settings, and then just create texture. And on Vulkan, all of that stuff is like way more complex. Same with launching compute passes. That's super easy. So you can begin a compute pass, set a pipeline, set the bind groups, and then dispatch. This is way nicer than Vulkan, I think. So in here we have stack nodes, we have triangles, we have BVH nodes. Yes, triangle, BVH node, GPU data. Okay, we have all this stuff. Let's see, intersect ray triangle, intersect ray AABB, traverse. So here we set our camera direction. We don't need any of that. We mostly are concerned with the traverse part. I'm gonna remove this. I'm first gonna remove all the stuff that we don't need. We don't care about this. We do not care about GPU data. Oh yeah, maybe I should increase the font size. I think maybe this is better. I use a 4K screen, so I can read really small characters. I hope this is a bit better. Yeah, thank you for mentioning that. So, BVH node, stack node, triangle, we no longer have triangles, but maybe I should keep that. Let's see, triangles block, triangle block, where do we use that? Oh, we use this one. Triangles, triangle normal, we don't need that, we don't have normals. Traverse, intersect ray ABB, I think we need that. Yeah, so we're gonna intersect. Okay, so what we're gonna do is we're gonna create a stack, because when we're traversing our tree we need to keep track of all the previous nodes that we entered, because we're gonna do a search through our tree. Then if the count is greater than 0, that means we are hitting primitives. So this entire part is for when we hit a BVH node which points to primitives. If we don't hit primitives, we're gonna find our children in our tree, this one, like the first one and the second one, these are the two children of our BVH node. Then we're gonna intersect these AABBs. If we hit any of these AABBs, we're gonna go into that AABB. If we don't hit any of those, we will traverse up the tree, I guess. That's roughly it. Intersect ray ABB, intersect ray triangle. My cross, I don't need a cross product, I hope. Do I need a triangle? I don't need a triangle, I hope. Triangles be gone. Draw texture be gone. Let's see, how many lines do we have? 140. That sucks. Okay, so we mainly have to replace this part with the instance IDs that we're gonna hit. So let's get to it. In intersect, we're gonna put intersect over here. This is our WGSL code. This is the code for my old project, my BVH traversal code. Let's see. Oh jeez. Traverse volume, yeah. Intersect instance, yeah. Intersect world, yeah. Okay, so what do we do here? We get our array, we intersect world, and then we use that intersection to do a bunch of stuff. So in here, this is where our BVH traversal has to happen. Let's see how we can make this work. Oh fuck. Don't click on that. Okay. We're gonna use BVH nodes, BVH indices, bloop bloop, BVH node, BVH indices, yes. Then we are going to grab this, go all the way down, grab this, loop, and start translating this. What exactly is BVH for? Just an optimization for grouping 3D objects into bounding boxes over and over? Yeah, exactly. That's exactly it. I can show you a bit. Let me check. So this is Jacco Becker. He made a gigantic blog about BVHs. So what a BVH is pretty much is we're gonna create a red box around all our objects. Then in that red box we're gonna create smaller boxes like the blue ones, and then the smaller boxes are gonna have even smaller boxes. And this way we know, like, we got a spatial data structure of yeah, where all of our objects are, and we can very quickly query rays against these sets of axis-aligned bounding boxes, and that speeds up rendering. Currently I don't think any of my code works because let's see, I can remove this part, and then you should be able to see what I currently have. Let's run it. Okay, you're not seeing anything because I should switch this. Okay, this is my winit window. Okay, so there's a bunch of objects in my scene. There's a bunch of trees. There's a bunch of things that should represent rocks. And then there's these little things flying around. And what I currently do is I generate a ray. I check if that ray hits any of the objects. So I test all axis-aligned bounding boxes of every object for every ray. And I think that's about 300 objects. So adding a BVH will, yeah, allow us to do way less of these AABB checks. So let's get, what was the problem I was having? Let's remove this, remove this. Right, I don't know how to WGSL spec. Let's see how you create a static array in WGSL. Array. There we go. I think this is it. What? This is really the most. Really? Can't we just use C-style array? Thanks. Yeah, it's super low res, but I kind of like the low res style. Oh, you're just trying to use it for your raycast check at the moment? Yeah, I try to use it for my raycasting to speed it up, and I try to use it for. So you saw the purple things flying around, right? I want to add voids to them, and they have to avoid terrain then. So then I'm gonna also raycast their physics stuff, so they don't intersect with the terrain. And that also has to happen somewhat efficiently because I don't want people to require like supercomputers. Jesus, there's so many arrays. How do you use an array in here? Sorry, it must be this thing. Array. DS concrete and constructible. Can I FN array? It's gonna return an array. Okay, let's see if this works. Nope. An array of stack node. I think that is defined over here. Nope. I do not have stack node defined. Struct stack node. What is it? It's a uint and a distance u30 node. BVH node index u32 and a dist, which is a f32. Okay, we can go back. Stack node, yeah, we now know that it exists. We're gonna use 32. So our tree can have a maximum depth of 32. Should be fine. I don't know, do 32 or 2 to the power 32, and that's how many instances we can have if our tree is perfectly balanced. But I think that should be fine. Let's see. Okay, we can use our stack. There we go. Node index. Stack pointer. Yeah, while true. That makes sense. It should all work. BVH nodes. Node index. Yeah, it should work. Do these kinds of for loops work? Yeah, they should work. This is going to be a var. This is actually also going to be a var because we're going to edit these. Intersect right triangle. Okay, we're going to add a massive to-do here. Intersect instance. If stack pointer is 0, we're going to break because if we hit something and we are already at the top of our stack, then that means we have traversed the entire world, so we can stop intersecting the world. In here, we're gonna var t float max. I don't know, 1e. Ooh, okay, this is never gonna hit that. Wait, let's do it like this. T max equals this one. T max in here. Well, t is greater or equal to rate t. So this is the part where we traverse up the BVH when we just intersected an instance. If our stack pointer is 0, that means we return. That makes sense. If our stack point, okay, if we don't return, then we decrement our stack pointer. We get our new stack node. SNDist. Okay, so we get the distance of our stack node, and we get the node index. Our node index becomes the node index from the previous stack node. So this is how we keep track of our where our previous steps in our tree. This is where our previous steps in our tree, the indices to the BVH nodes, are tracked. We need that. And then this distance t, well, t is greater or equal to rate t. So we ignore all the parts where our ray.t, I guess. Yeah. So in here we ignore all the nodes that have a t which are greater than whatever we already currently hit. So we're traversing through a bunch of instances. If our distance to our hit point is further than the hit point that we already hit, then we shouldn't traverse that instance because we're never going to hit it because we already hit something closer. Rate t, okay. Volume intersection. Yeah. Intersection. Where do we make this? Yeah, okay, so intersection t, we should use that in here instead of rate t. Yeah, because we want to use our intersection distance. What does your ray class look like? Let's see. It's not that complex. So our ray class is our struct. So we have an origin, effect 3, so 3 floats of origin. We have a direction. We have a t0, so this is the closest possible point that it's gonna hit, and we have a t1, which is the furthest possible point that it can hit. So if we hit something, we're gonna set t1. If we actually hit a voxel, we set t1 to the distance to that point. If we hit a bunch of AABBs, for example, and we no longer want to do any calculations on the part from the start of your array to the AABB, then we set T0 to the distance to the closest AABB. So this allows us to like skip regions if we want to. Okay, so let's continue. Stack pointer, yeah. Okay. Child 1. Let yada yada yada. Intersect array ABB. Makes sense. This is gonna be a let. This is gonna be a let. Yeah, there you go. Let's see. This looks fine. This is the part that we need. That part is gonna contain this part. Let's see if we can get this correct immediately. Our BVH nodes. Oh right. I need this one because this is the index that we're gonna. Yeah. So if the instance that we want to hit is in our BVH node, the left first instance plus I, because in each BVH node we can have 1, 2, or 3 model instances depending on how our BVH is built. So we're gonna iterate in this for loop. We're gonna try to hit all of them. Then if our volume intersection is hit and our volume intersection hit distance is less than our current intersection hit distance, then we're gonna save all this stuff because we need this stuff for rendering. This is pretty much your G buffer. Okay, that should work. This is updated in here, so that should work. BVH node index, that should work. We're gonna fix this later. Ah, this is annoying because all our array stuff uses different naming. Array.o, array.b. There are right. Wait, let's immediately try to fix this because this is what my AABB intersect ABB function looks like. Position direction, yeah. Intersect ABB, and then array.o, array.direction, like this. And then this ABB should be something that is sane, so we're gonna use yeah, so our ABB is not gonna use this, it is gonna use child 1, which is gonna be that's kind of annoying. Because this just uses ABB ID child 1. So this is going to be the index of our BVH node. Our BVH node. Let's see. So in here we should be able to grab the we should be able to grab this one. Oh. And we should be able to grab this one. And then we have 2 BVH nodes. And then our BVH nodes contain all this stuff, which we can use to fill our ABB. How do we fill our ABB? Like this. Min X, min Y, min Z. Oh, min Z. Like this, like this. Max, max, max. Oh, right. Like this. Bloop, 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 bloop. And bloop. Let me quickly check something. Okay. Okay, intersect ABB. This uses child 1's. Wait, let's make sure that the first one is min. Yeah, okay. First one is min, second one is max. Fact 3, F32. Okay. All of that makes sense. Then in here, in the next one, dist 2, we're gonna use child 2 because we want to hit the second child. Remove this one. Remove this one. Have an idea for a game you want to make, or are you just making your own voxel engine for fun? I'm planning on. I do have sort of a plan for the game, so yeah, this is not gonna win. But the plan is to have these little purple balls flying around. They have to look a bit scary. They're gonna attack you if they spot you, and you're gonna have to kill them. And you can walk to, like, you saw a little island with a few trees and rocks. You're gonna have to jump over those rocks and through the trees and yeah, get to different islands and then kill the purple thingies there. That's pretty much it. And I am planning on adding a bunch more like particle effects, so that if you kill the purple thingies, it's actually going to be satisfying. And I don't know, it's going to be a simple shooter, I think. That's the plan for now. Okay, so we have a distance 1, we have a distance 2, back 3s, yeah, makes sense. Let yeah, if you can, you should like dodge the purple thingies by standing in the trees, and then they don't notice you. But then if you're caught, you have to kill them. Or yeah, I guess you can sneak around them. I never thought about that, but that's a nice point. Distance 1. So if distance 1 is greater than distance 2, then we shoot first. What even is this distance? How do I calculate distance here? How did this ABB intersection function ever work? Because this doesn't work when this is gonna return the wrong value when T near is behind the player, I think. Oh no, but it should do that. Okay, so then it's correct. Then in our ABB intersection function, what do we return? An intersection. An intersection has a T0. Again, T0 stands for the first thing that is hit, so the first wall going into the ABB. T1 is the outgoing point. This one is greater than this 2. So then we swap them, I guess. Child 1 and yeah, okay, so child 1 and child 2 are swapped. The children and the distances are swapped. In here we're gonna use Tmax again. Oop, oh wait, but this is gonna right. This is gonna be annoying because this one I should use. I'm currently not checking if I even hit the ABB. That's a problem. Intersect ABB. Actually, I'm just gonna use the raw intersections. If this dot t0 dot t0, then I'm gonna switch them. If dist 1 dot hit, I guess hit intersection, yeah, hit. Hit is gonna tell me if we actually hit something. If we did not hit something in this one, if we did not hit something, if our stack pointer. Do you have big monitor by any chance? Yes, I have quite a large 4K monitor. You also can't read it, I'm gonna guess. Yeah, I don't really know what to do about that. So sad. I can make it even bigger. If you're on phone, then maybe I don't know how much bigger I can make it, because it might have to get real big. I just made it a tad bigger, but is this okay? Can you almost read it now? On a TV? What? Okay. Oh my god. Oh, this is getting real big though. This is kind of stretching it. Just zoomed into the portion of the screen. Okay, you could do that. I guess that's not very much an option on TV. Okay, if we did not hit anything in our first intersection, if our stack pointer is 0, then we're gonna traverse up. This is gonna be a var. This is gonna be, if you can, shouldn't take too much more bandwidth, I think, since most of the screen doesn't change next time. Readable now. Okay, that's good. Yeah, I can try streaming on 4K. We'll try that next time. Okay, Tmax. We're gonna put that in here. So here we have almost exactly the same loop that we had in here. We're gonna traverse up the stack. If our stack pointer is 0, then we're gonna return array.t. This should be intersection.t, I think. Intersection.t. The size is much better. Sorry, I have to look at huge text though. That's fine. Yeah, I'm used to my like very small characters, but maybe this is probably better for my eyes anyway. So SN dist, yeah, BVH node index. That makes sense. Else Node index is going to be child 1. This is not correct. This should be child 1. This is a BVH node, so where's our BVH node? Oh, this is kind of annoying. I guess it's this one. And then in here we have this one plus 1. I'm gonna format this like this. Oh, like this. This is ugly. There we go. Float max. We're gonna use tmax again. Okay, so our node index becomes the node index that we use to get the node index that we use to get child 1, and then if our distance to 2, so okay, so in here we should also check if we hit it. Okay, so if we did hit let's see. So this one should go. The flow goes as follows here. If we did not hit something at dist 1, we're gonna traverse up. If we did hit something at dist 1, then we're gonna use I don't know, coding videos are kinda cool. That's why I started streaming today. I watched them a bunch as well. This one hit. Okay, so if we did hit something at this one, then we're gonna save where we grabbed this one. That's gonna be the node index. If we did hit something at this 2, then we're gonna add a value to the stack. This value on the stack is gonna have the distance. Oh wait, this should be t0, I guess. Yeah, t0. Maybe. This is going to add something to the stack pointer. Stack pointer is going to be incremented. This is going to save the point where it got this 2 from. Okay, so do we have everything now? In theory, probably. T1 is the exit point for the first object hit, right? Yeah, exactly. Well, of T1 generally means like the second intersection point. Or yeah. Yeah, the furthest that your array can hit. Because I also store T1 in my array, and that is always initialized at like some insanely large number. Basically your viewing distance. What's wrong here? How do I make a stack in... why do you need entry and exit point? You using the width of what you hit or something? Well... oh, maybe this isn't correct then. Well, because we can reject part of our... I think we can reject part of the region that we hit. So this is for reordering which ABB we should hit first. So that should be the closest. So we swap if it's not the closest. Let's see. In here we use the distance t if t is greater or equal to intersection T. So we store T0 in here, and then we read it again in here. And then in here we check if the T0 is greater or equal to the intersection T. So if the T0 is further than the current intersection, then we're definitely not gonna hit it. That's good. Do we use T1 anywhere over here? I guess not. Right. Okay, how do I get this to work? I'm gonna switch to Firefox again because there's an overload. Yada yada yada. Can I just... Really? Are you kidding me? Same values with the 0 valued members. Okay, that's quite a lot easier. So we should be able to do this. Oh, right. For is this gonna work? Let's see. This is gonna crash. Okay. What is wrong? Assign expected assignment or increment decrement. Oh right, this doesn't work. Let us in. Let us in. Yeah. Let's see if this works. So what code to write in all comments in a way the code is supposed to work. All comments only, just replace comments by code for run into countless bugs and problems. That's roughly what I do as well. I don't always write out all the comments, but I usually try to find like some website like Jaco's tutorials for BVH ray tracing, and then I try to follow each of the steps and then implement them one by one. var instead of let. Oh, right. Huh? Why? Oh, that makes sense. Var, because we're switching this up, and this one as well, and this one as well. There we go. What's wrong now? What is this kind of error? Intersection world is invalid. Expression 190 is invalid. Composing zeros component type is not expected. In Godot, a game engine together with FFmpeg, are dealing with two badly documented libraries. Oof. That's sad. But working with Godot sounds cool. I've heard many good things about it. Why is this not okay? It should be okay, I think. Expression 190. Stack node. BVH nodes. This 2.t0. Composing zeros component type is not expected. What does that mean? Stack node. This How's this defined? U32, F32. Stack node. Wait, how do I construct my BVH node? That's exactly the same, right? What class interface and overall structure I'm trying to create for my own libraries, etc. So I usually work with a whiteboard as much as I code. You from the Netherlands or Belgium? Yeah, I'm Dutch. Are you also Dutch? So many Dutch people around these days. This works fine. Oh, Belgium! Belgium is so nice. Love going there. Why does this not work? So sad. Validation error. This must work. Component type. Japan and Dutch has been degrading to the point that it's strong attack. Oh. Konnichiwa. Wait, should I do this then? Just gonna say anything else? No. Let us see. Not index. Why is this wrong? Stack. This contains a bunch of stack nodes. Yeah. And I set this specific thing to that. Okay, let me create this stack node here. Let's stack node. And then we're gonna add the stack node like this. What's wrong now? Composing zeros component type is not expected. How is this an operation that isn't possible? Oh, don't worry. Talk any language you want. Well, I would love to understand what you're saying, but it's fine. Stack node. Would this be it? No way, this is it. Yeah, you clearly understand what I'm writing here, I guess, so... What's wrong here? Cannot convert either. Oh! Thank you so much for that error message. Let's see, does this work? do I convert to? How do I cast my numbers? F32. Yeah. Is it an I32 in here? No, it's not. So a U32 should be fine. There we go. That's a different error. Invalid function call. Intersect instance. Flame intersection. Where are you? Argument 1, value doesn't match the type. Yeah. Intersect instance, it should be U32. U32. We're gonna do it like this. What do you mean eggs were invented? How were eggs invented? Okay, so in here we break. Why don't I always break? Because this is a return. 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 There we go. You want to go to Germany? I guess that's what you're saying. Store of 48 or 84 into 8 doesn't have matching types. BVH node index. Which? Assign BVH node index. Maybe I should just. How did I do that here? It's a UN. Node index. U. Oh, let's go. See you later. The return value none does not match the function return value. Where's this last return? See ya. Sort of 180 into 8 doesn't have matching types. So left first, let me guess. Left first can be, yeah, that's an I32. Well, net zien waarvan. Okay. Or culture, yeah. Yeah, our culture comes from a strange place. When 80 into 8 doesn't have matching types. Where's this? 275. This one. This should always be correct because. Oh my god, this will work. Oh, it crashed my drivers, didn't it? Ow. Can OBS recover? Is my stream still going? What frick happened? Sick, it's green. I guess it works. Let's see, what's the latency like? Okay, it works. Okay. Crashing my graphics drivers is not good for the stream. We come from Dutch settlers and some other European settlers, so it would be cool to see where some of... Yeah. Do you also eat pancakes in Africa? It's like a Dutch staple. Intersection. Parent device lost. Okay. Do you eat pancakes? I don't know. In the Netherlands, we have these, I don't know, doughy pancakes that we make. I don't know if that's also a thing in Africa. We put syrup on it and sugar. Pannenkoek, yeah, exactly. You know it. Plaatcookies. Stroopwafels, I guess. I don't know plaatcookies. In Dutch we have stroopwafels, which are cookies with syrup in between. Je biltong en boerworst. I don't know what biltong is. I guess that's a fish. Boerworst. Definitely boerworst. Milk dirt. I don't know. I don't know what that is. Okay, how do I not make my device lose stuff? Let's see. Step. If step is larger than 20. Plus I. What do you mean step? What's wrong? Oh. There we go. I don't know what milk dirt is. Okay. Step. Let's see. Will we not crash our drivers if we take 20 steps? There we go. That's better. Yeah. Love milk. Okay, so there clearly is a bunch of stuff wrong. Let's see. If we BVH nodes, yes. Return intersection, if this, that. Can I just do this? Actually, I shouldn't do that. I should put it in here. Probably. Should I? Because yeah, let's put it in here. We hit it Color. Yeah, the color is gonna be. In this case, it's gonna be color plus 0.1 volume intersection T. We're not gonna update this. Normal, we do not care. Back 3, F32, 0, 0. Do you eat rusks? Beschuit? Yeah, we do, definitely. We always eat a cookie with our beschuitje. Or a cookie with our coffee or tea. This is a bit sad. Are we not intersecting anything? What is that? What? Why did you fall over? Just because of my answer? No way, right? Okay, so let's see. If we put this in here, it's gonna return with a slightly tinted thingy for the entire screen. It should. It's not. What? Intersect world. Return intersection. What do you mean FN? Oh, because this is all inaccessible now. Okay, like this then. What is going on? Oh, I should update my T. Of course I should. This is gonna be T max divided by 2.0 or something. Doesn't matter. Yeah. No, it shows a gray screen. Oh no! Yeah, we do need that. Don't worry. Well, actually, when I'm at home, I don't. But when we're out for coffee or tea somewhere else, then people always give like a little cookie. I mean, this is interesting. I don't know what's happening here. I don't think it's supposed to do this. You can see the BVH, which is cool, I guess. It's just kind of sad that it's something is. That's correct. No, you can even see the BVH moving with the. That's sick. You can even see the BVH moving with the little slurpees. I think they're called. Yeah, slurpees. Okay, so a bunch of stuff is wrong now. Can I remove this? Let's see if hot reloading still works. It does. That's good. Okay. Yeah, the BVH seems to work, but returning hits on BVH instead of leave. Yeah. That's what I'm currently trying to do. was. Alright, maybe I should increase this. Andrew. I don't know if this is gonna help at all. Jesus, this is seizure core. Okay, so it's clearly not. The fact that this is taking ages means that it's clearly not exiting correctly, because it should just return at some point. It should just return on something. What's going wrong here? Our stack, our node index, our stack pointer. We take a certain number of steps. If our count is greater than 0, this means we're hitting things. Yeah, I don't know how possible recursive algorithms on the GPU. I don't know, maybe it's already possible, but you're right. Stuff like using a custom stack to like keep track of stuff, then definitely a recursive method would be like way easier because you can use the actual stack. Okay, so there's a few things that can happen. Okay, I'm gonna remove you. Let's see, from 0 to these intersections are checked. Yeah, it's all on the GPU. These are compute shaders. So each of these programs is being ran for every pixel. That's why we have texture stores and like all this stuff, because this is an index into the thread on the GPU, and then we use that thread to grab a ray index, and that ray index, or that ray, we use to do our intersection testing. This all makes use of, let's see, this all makes use of this shader language, web GPU shading language. Well, they're not that complicated. The most important thing to know is that you have this in your shaders. You have like one starting function, so that's this one, and for each thread that you start, this function will be called. And on the GPU you can launch thousands of threads at the same time, so that's why on the GPU it's like very good to do parallel stuff like ray tracing an entire scene. So yeah, it all has to be implemented on the GPU. But anyway, that also results in different, how do you say that? You're limited in some ways, so you can use recursion, I'm pretty sure. That's why you have a custom stack over here. And yeah, there's a bunch of limitations, but it's also insanely fast. The raw throughput. But anyway, let's try to find this bug. Stack pointer 0. Yeah, on the GPU you can launch a few more. Each of the threads is slower, and all threads GPU works in such a way that they're clumped up into sets of 32 threads, so all 32 threads execute exactly the same instruction, but it can work on 32 values. So and then you have a bunch of those sets of 32 threads. So yeah, if you have a bunch of work that is can make use of exactly the same instructions, so no branching. If you branch, then half of the or part of the threads can branch, and half of or part of the threads can not branch, and then you're only executing instructions of part of your threads. And then things become inefficient. So if you don't have a bunch of branching going on, then the GPU can very efficiently calculate a bunch of stuff. But why doesn't this work? I really don't want to open up a debugger. Also, it's super weird that right now you can see a bunch of the bounding boxes and the models, but if I remove this, you don't see any. Not running in parallel and in constant time, since all branched code is executed always. It's so cool though. Yeah, it is. Is this one broken? No way, right? Intersect instance. Left first plus I. That's correct. Make some entity component system for a game engine that use that in some way too. Yeah, you can. That's what most physics simulations are like. Just gigantic entity component systems. We could, in theory, also use implement my voids, so the little purple thingies flying around on the GPU, because there's also a bunch of objects that have exactly the same code path. Yeah. This doesn't make any sense. Okay, now it doesn't show anything. Now it does show a bunch. I remove this. Huh. This is fine. This is no longer fine. Why? Volume intersection. T. Yeah. Well, this doesn't make any sense. Um, 20 minus T. 20.0 F32 T. No, step. Okay, I've only gotten into working on the small game engine last year, but it's so nice getting to deal with so many different aspects of software engineering. It's awesome learning more about game engines. Wish I had another life where I could do just that. I know, right? I also want that. It would be amazing. But I have to work sometime. This is so weird. Why does it... No hit voxel intersection. What is this? This should be the default. Yeah, I tried to. Been working on this for a few months now, on and off. Oh my god, they're so back. Let's go. But they're only back part of the time. Why is that? Why is it being silly? So can I now put it to this? Yeah, I can. Okay. Well, I almost do exactly the same. I am a graphics programmer, and I have done a bunch of stuff with voxels, but more specifically volumetric rendering, so smoke and fire. And I implemented like some data structures for that. And we rendered those in my company. Yeah, it is sick. Well, it's sick when I get to work on it. Sometimes we have different like parts of our code base that need work, and then it's a bit less, a bit more boring. But working with voxels is great. Yeah, it's game related. We don't publish games, but we have a game engine and we do research for companies like AMD. So yeah, I don't know. We try to implement some different things, and then we talk to people about what works, what doesn't. What? Yeah, I'm still going. Of course I'm still going. Hello? Having a great time. Look at my trees. They're almost like... I don't know. They're just a bit poppy. The company I work for is called Traverse Research. Traverse Research. Sick. Never take meds. Why would you? This stack pointer. Okay, I really have to figure out this. What is going wrong? Left first plus I. That's correct. Okay, in here. If we did hit something, if our stack pointer is 0, then we break. That makes sense. Because We're gonna traverse up our tree. We're gonna why do I even have this? Because I do exactly the same check over here. If t is greater than... I don't think I need any of this. I hope. Like this, 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 this. It keeps doing the funny thing. Yeah. That's good. Multiple game engine renders all other engines obsolete. Yeah, I'm sure your engine will be great. I'm sure you'll outcompete both Unity and Unreal at the same time. You can do it. Yeah, in here. Okay, this works fine. T equals T max, yeah, T due to distance, yeah, if stack pointer equals 0, then oh yeah, I'm also definitely doing that. My engine is not optimized at all. The only reason why I want this BVH is because physics would be completely impossible if I don't have it. But there's a reason why my game is currently rendered in 360p, because I don't want to optimize the rendering code. And yes, my game is rendering in 360p, as you might be able to see. If stack pointer is 0, then we return the intersection. Otherwise, we decrement the stack pointer. Then we use that stack pointer to grab the latest thingy on from the stack. We use t, which is going to be the distance. If t is less than the intersection t, then we're going to traverse our stuff. Yeah, and our node index becomes BVH node index. Yeah, that makes sense. Okay. And then we continue, so we start at the top of our loop again. Yeah, makes sense. Child 1. We take the BVH node, which the current BVH node points towards, and the other child that the current BVH point talked about. Trying to make a really abstract framework that makes prototyping games easy, but I'm not really thinking about adding many rendering features and such. But hopefully my API is built well enough for features to be added in the future. Yeah, sounds great. I love prototyping games. Intersect A with B, yeah, min, max. We flip them around. What would happen if I did this? Nothing much. Okay, okay, so then the other part of the logic comes in. Wait, let me see. Oh, you can't even... Why is this window like that? There we go. That's way nicer. That's more what I see. If we did not hit anything in this one, then we should go to this 2, I think. Because now we're skipping this 2. Okay, there's clearly a logic error here. I think, why did this work? How did this code work? It's float max. Ideals in a powerful high-level language like Scala then actually make a good idea. Yeah, I freaking hope so. I want to end the stream when it works, but let's see how long this stream will take. Yeah, I think making a game in Scala would be great. I guess it has the same like benefits that Java has for Minecraft, where you can, I don't know, add a bunch of modding support and stuff. No, I don't have to go. I have like vacation, so I'm a bit hungry and want to finish this. T is greater than intersection T. Yeah, makes sense. How did this code ever work? Does this code even work? Let me check something. Ray tracer. Trace. I mean, this should work. Let me go back and check whatever Yako wrote. Let me turn this off. One more thing, subdivide. Yeah, we have subdivides, traverse. Yeah, I think now I used the Tilas and Bilas implementation. Just makes it very easy to write complex systems but still have short and readable code. Just helps you work a lot faster and with less bugs since it's very strongly typed. Ah yeah, I love strongly typed languages. Just like Rust. Woo. Okay, so this is the main thing that I have to implement. But I guess Scala is higher level, so maybe it's a bit more productive. Let me see. Oh, I got a message from someone. Okay, not important. Yeah, we grabbed a node. He is a stack of 64 thingies. We intersect the ABB. You swap if this one is greater than this two. if stack pointer 0 break, yeah. Else node equals stack minus stack pointer. Nice naming, I see. That's fine. I think you don't need all that performance. Especially if you're writing stuff for the GPU, it doesn't matter at all. Yeah, just do T0. I think Rust is already a pretty high level language if you use the correct libraries, but there's just a bunch of complexity in its borrowing system, so that's why it sometimes takes longer than, I don't know, you would expect, I guess. Intersect ABB, where is this? Is this written down somewhere? No, it's not. Can I find this somewhere? Intersect ABB. What does it return? A boolean? No way, it returns a boolean. Fast arrays. Intersect ABB. Yeah, now it returns a float. Return tmin else. Okay, so we always just copy paste that into ChatGPT and tell it to fix your code. I wish I could try. Kinda don't want to try that. Intersect ABB, yeah. If this 2 is not... Okay, so if this 2 hit something... Yeah, I also have that part. What do you mean? Yeah, I've also never seen it work, or I've never seen it fix my code. I have seen it generate awesome LaTeX, like the markup language, but proper code, like fixing proper code, doesn't really work, I think. This is ordering correct. Yeah, first we... Yeah, I guess that's the best idea. Using it for learning. Oh my god, is my BVH wrong on the CPU side? Could that... No way, that's it. It would be stable, I think. T is greater or equal to intersection.t. Stack pointer equals 0. What's wrong with my trees? Come on. How am I gonna debug this? I'm gonna re-add these. Bloop. Hello? Okay, you should also stop spamming my console with this stuff. Info. Which one is it? Is it this one? Uploading voxel buffer. This one. I'm gonna remove you. And I should be able to not have a spammy chat log. Thank you. Then in here, doesn't do a lot anymore. What the hell's wrong? Oh, you crashed. What is that? Invalid return. Makes sense. Return intersection, yeah. Ba-ba-ba. What did I change? What the hell did I just change? BVH. Create bind group. Intersection bind group. BVH indices buffer. Buffer binding size is 0. But these should also all be 0 if... What the hell did I change? Is it literally this? Oh, okay, so that print, this info print saves my program for whatever reason. This one should be like at 100. Yeah, that works. Okay, good. Wait, did we switch to Lord of the Rings? No, it's Skyrim actually. It's a 10-hour playlist or 10-hour video of Skyrim ambient sound. But it's very calm and chill. I am kind of stuck. I guess we might be doing something wrong here. Because we are not using... I think I know what might be wrong. We are not using our BVH indices. BVH indices, if we then use this one, that is more correct, I guess. Why is it like this though? Why does it flicker so badly? Maybe I should disable the rebuilding every frame. Ticks per second. Let's see. Can we go to 1 tick per second? Damn it. One tick timer instant.now minus duration from seconds. Ticks per second. So we do this thing like this. We should reset. We should set our tick timer to be exactly yeah, our tick timer should start exactly such that it immediately fires the first tick at all times. It does not. It still does not. Why is this 0? What's wrong with it? Build BVH, yeah. Uses the instances. Should I put the update world above here? Update models does all this stuff. Do remake instances. Should I put this in here then? Update models. No way. I don't think there's any way we should update the world before we're making the instances. Actually, I think we should. Maybe. Gen GPU models. Maybe I should put this in here. I'll try that. How do you do debugging for GPU-based code? Well, one of the easiest things to debug it is by drawing pixels with certain colors. Because if you draw, I just did that. Why does this not work? Oh my god. On tick timer, minus that, then it should immediately fire this, but it doesn't. Ugh. is this? Indices. Oh, I guess this was correct. Wait, in here. Instances, yeah. What is in BVH? Indices, BVH. Because you can't log to the console, or can you? You can, there's two things you can do. You can open up a debugger, and with the debugger you can capture a certain frame, and then you can read all the data in your different buffers and textures and have a look at it that way. Or you can color pixels indeed. So if you color your pixels black, but for each step in your BVH traversal you color them slightly wider, then you will see exactly where your BVH is. And that's very nice. Indices, BVH nodes. But yeah, if you want to use proper debugging tools, you should use NVIDIA has one, AMD has one, and there is RenderDoc if you don't use ray tracing. I don't use hardware ray tracing, so I could use RenderDoc. Yeah. Okay, I honestly don't even know why binding size is 0. Why is this an issue? In buffer data buffer. Yeah, this buffer, my voxels are empty now. Yeah, it's super useful. And you can also, for timings, you can capture multiple frames and then check out how long each compute pass takes, and it's quite extensive. But most tools seem to crash a bunch, which isn't great. And also, if you create an infinite for loop or an infinite while loop on the GPU, then your drivers crash. So debugging is kind of hard. I'm completely out of it. Why is this not working? Why are we not generating a model before? In here. Build BVH, update world, remake instances. Where else do we set this data? Should I just start doing it every frame? Yeah, what are they gonna do? Tell me not to do it every frame? So I currently have a white screen. That doesn't sound good. Okay, this is way too slow. I cannot upload my buffers every frame. Not possible. greater than 1. Greater or equal. There we go. Okay, so now it's bugging on exactly my update timings, so I'm gonna assume that my BVH is perfectly fine. No, my BVH isn't perfectly fine. My GPU code is perfectly fine, but my BVH creation is wrong. Let's see. Indices, BVH nodes, default, yeah. Okay, wait. I'm gonna do one last test. I'm gonna check if my BVH, this one, is being colored somewhat correctly if I do this. Huh. Yeah, I don't think the CPU code is correct. Because this seems stable now. Truncate, what does truncate do? Shrink to fit, yeah. Set bounds, ABB, instances left, yeah. First amount instances, yeah. Set bound, yeah. What are we gonna do with this ABB? Shouldn't I set it somewhere? Oh, right, it's being set in here, yeah. New node index is 2, instances, subdivide, start and pool index. No, it's current BVH index. The start index, yeah. Okay. I centroids like this. Transformed ABB min plus the... Oh, this is completely wrong. Minus this. This will be a lot more correct. Okay, so now my centroids are more correct. Yeah, instances, calculate bounds. Calculate bounds correct. Why am I doing it like this? 3, 2. Wait, isn't there a vec3 min? Yeah, okay. Vec3 max. Oh, that on the wrong way. Oh. Max point, min point. So now in here we have our first and our amount. So we iterate from first to first plus amount. Then our I becomes I of use size, yeah. I guess, sure. Our centroids are also indexed using the indices. That makes sense. Our vertex, max point is max point. Min point is min point that. Yeah, min point, max point, yeah. Transformed ABB max, yeah. This makes sense. Indices I. Do I use the BVH indices correctly? I guess so. Node index, yeah, that's fine. All of that uses their respective indices correctly. Indices.swap. I've got to go. Thank you for reading my messages. Hope you get your code working soon. Thank you. I'm also probably gonna go soon. I can't get it to work, like, currently. Thank you for being here. Dat means self-centroids equals instances iter. Yeah, okay, that maps 101 with that. That's good. Indices, BVH nodes. Left first, 0. Count is that thing, subdivide. When we subdivide current BVH index, left first becomes index. And I guess it should become the pool index, because we set the pool index at 2 at the start. Yes. If self.bvh nodes count is less or equal to 3. Yeah, pivot partition. Did I fuck anything up here? I hope not. So bound partition. Our partition is exactly the same. let's see how it differs. Did I miss some crucial parts? Indices. That should be correct. BVH nodes is, yeah, okay, then if we build the BVH, then we get the thingies and the things. Calculate bounds. Yeah. That's exactly the same. Okay, so our truncate, shrink to fit, triangle, self, indices, ether, map. Okay, so here we swap the triangles in the end to reduce the indirection. So let's have a look at the subdivide. That's the same, that's the same, that's the same, that's exactly the same. Doesn't matter. Start, yeah, index, yeah, left count, yeah, start, left count, yeah, false, yeah, set bound, yeah, right count, current BVH index dot count minus left count. Count equals right count. Calculate bound. Pivot. Right count. Instances. False. Yeah, makes sense. Set bound of the index plus 1. Yeah, makes sense. Subdivide. Start. Pool index. Yeah. BVH node count equals 0. Okay, this is correct. This is exactly the same again. Calculate bounds. Oh wait, but this one. Oh no, that should be correct. Starting count, true. Okay, then we start partitioning. Access will start, yeah, pivot that, yeah. BB1 count, start, pivot, BB2 count, yeah. False, false, yeah. Get the area, yes. Partition shuffle at the end. Yeah, get area. Should be exactly the same. Partition shuffle. Here we do, yeah, it's less than 1 position. Yeah. I plus equals 1. Yeah, else self indices swap I as U size and as U size. And minus equals 1. Yeah, this all makes sense. I think. Yeah, it does. Centroids, yeah. Calculate bounds, okay, the last part. Last part of our BVH build. Max point equals max point max of the vertex. Yeah, self-centroids. Yeah. Then we grab some index. Should I do this? This shouldn't be necessary. And it should result in exactly the same BVH. In theory. Are my intersections correct in here? I think some of my T's aren't correct. Flame intersection dot T, yeah, that one is surely correct. T equals T max, yeah. If, well, T is greater or equal than intersection T. We keep stepping up, yeah. If this T0, yeah. Position direction, yes. First position, then direction. T0, or should this be T1? Origin redirection, yeah. Intersect instance. Instance ID, yeah. BVH instance. Left first plus I. What's the problem here? That is clearly not it. But the problem is this T that we have here is T1. T is greater than intersection. Sec node, yeah. Okay. Minus equals 1. Left first. But shouldn't this... Why? T equals T max. Well, T is greater or equal to intersection S and dist. S and dist is T1. No, this should definitely be T0. Yeah. Intersection of T. Anyway, I'm gonna grab some lunch. And I'll be back soon. See ya. Oh. Hello. I'm back. Let's continue with debugging this. Whatever's happening. I got my coffee, I got my... just ate some lunch. Let's get back to it. So, where were we? We're at the BVH. We have our BVH nodes. We have our count. We have our axis aligned binding boxes. We have our arrays. We don't need these now. BVH contains BVH nodes and indices, and centroids. Our BVH nodes will become the tree, and this tree will point into indices, and these indices will point into both the centroids and the primitives that we have. The primitives that we have are model instances. These are voxel. Yeah, these are like voxel models. So currently, what's happening is this is happening. So let's see how we can fix this. First things first, I'm gonna start inside. Let's see how I can do this in the best way possible. Probably just stream this. Let's see. Get Goxies, target, debug, Goxie select client, open. In here we're gonna launch frame debugger. We should have some things on screen. Okay. Let's capture this. Is it done? I hope so. Let's have a look at our resources. Let's have a look at our material, motion, normals. No. Camera buffer, descriptor buffer, redirection. Where's our BVH nodes? And we're gonna configure these to be factory, and actually float 6, UN and float. I think this is their general. I think this is their general structure. Count. Okay, so this one's empty. This one points to this one. This one points to this one. This one points to this one. That all makes sense. Then we go to 8, then 10, 12, 0. And we have a 1 here, or a 3 here. Yeah, okay, this makes sense. So except for the okay, all of this makes sense. Then we go back to coding. So let me quickly check if I can window capture. No video inside. Ah, that's trash. You can only select one of the inside captures. I guess I'll delete this one too. So the data on the GPU seems to be fine, I think. The only issue I can think of would then be the data on our GPU side. Let's see, our indices seem correct. And our intersection, yeah, BVH node index and a dist, yeah. And then min x, min y, min z. On the CPU side, this is the same, right? Yeah. Yeah, that's exactly the same. Transformed ABB min, transformed ABB max, inverse transform. That all seems correct as well. All this intersection code sounds like it should be fine. Where's this happen? Nope. BVH nodes count is greater than 0. Plus I. No. BVH indices, volume intersection. Yeah. Well, T is greater or equal to intersection T. If stack pointer equals 0, then we return our intersection over here. Because we're already at the top of our tree. Otherwise, we're gonna decrement stack pointer, grab the node from the stack, use SNDist as our new T, and then node index becomes our BVH node index. Makes sense, I guess. Let's see, which value should this be? T is greater or equal to intersection, so T should be smaller than the intersection, and T should be T0. Over here, we're storing T0 at all times. Makes sense. Then we continue. Because we continue with our actually, let's grab, let me check Yakko's implementation real quick. Break else node equals stack. So it should always continue there. Yeah, that makes sense. That makes sense. We always continue here. Okay, so then we continue to the next part. So we have a node which is pointed towards by our node index. Then we grab our left first next node by reading the BVH nodes. Then in here we intersect ABB. Our ABB is this thingy. Min, max. And in here min, max. We also intersect this ABB. This two, this one, this two. Intersect ABB. What's going on here? Max is greater than 50 max is greater than 0. Yeah, using the blah blah blah. The front side view tops from back side view improves. Okay, we use our origin redirection. Then in here, if our T0 then we swap both of these. Yeah, makes sense. This one also makes sense. If this one dot hit, if we did not hit something on this one, then we should go and utilize our stack. But is that always true? If this one didn't hit anything, node equals low hanging fruit, yeah. This 2 dot hit. Let's see, our stack pointer doesn't change then. Our node index becomes whatever this is, and we continue. Do we set everything up correctly then? Stack pointer should still be fine. Let's see. Uh-oh. U32. It's loading. Why? What is causing this? Could it be the ABB intersections? Let's recall the max, and max is greater than 0. And then we return min and max. Min and max. I think this is the correct ABB intersection implementation, right? Tmin is less than rate T, Tmax is greater or equal than Tmin. Can I still utilize this? Okay, so clearly some part of my intersection functions is wrong. Would this be grabbing the wrong nodes? Node index, yeah. Yeah. BVH nodes. Let's see, can we... instead of doing this, vec3, I'm gonna use this one, and this one. 0, 1. So clearly we go up a bunch there. It's less than this dot t0 dot t0 equals the max of 0.0. Okay, so what's the issue now? It's greater than this 2.t0. Yeah, we swap them. BVH nodes. Nope. That's gonna be wrong because now we only see. Yeah, now we see both of them. Stack node. I feel like if it's in one of the orders, it just doesn't. Just shits the bed. This to index, this to t0. Stack pointer, stack pointer is stack node. Stack pointer pluses. With BVH node. Okay, wait, let's set this back to like 500. Okay, so it is exiting correctly. Well, it heavily depends on what the BVH is. Sick. No voxel intersection hit. Wait a second, what do you do? When do you break? Ah, because it's a while. Right, that was it. Red origin, red already, red already, yeah. Okay, but clearly this, for some reason, doesn't do shit. Min X, min Y, min Z. Um, let's see. This one and this one. What does the only show stuff over there? What does it only show the first like 3 models? No. That is because we always intersect everything. And this one only iterates over the first few. If we intersect, we start here. But why is this so rude? So this is rendering a